Okay, now we're solving question number 7, the final question of this paper, which is a question about pulleys. Let's see what it says. One end of a light inextensible string attached to a particle A of mass 2m, alright. The other end is attached to a particle B of mass 3m. The string passes over a small, smooth, fixed pulley. The string is taut and both straight parts of the string are vertical. Both particles are held at a distance of 0.5 meters above a horizontal surface as shown in figure 4. The system is released from rest and B moves downwards. Okay, find the tension in the string in terms of M and G. Okay, so once again, although not for this part but for later parts, we are going to need this diagram again and again. So let's just copy it so that we can use it again and again. Okay, so something wrong with that. Let's try one more time. All right, now it works. Great. So we are supposed to find out the tension in the string in terms of M and G. In fact, you know what? Let's use it for the first part as well. It's always a good idea to show where the forces are acting. Okay, it just gives you a bit of a perspective. So tension, as we know, always acts away, and since this is one single string, tension will be equal. So you have the weight acting downwards, which would be equal to 2 mg, and then you have the weight of B also acting downwards, which would be equal to 3 mg. Now, because the heavier particle is B, so that means this is the direction in which the system will move. So let's first talk about A. A will move up, obviously. So if we're talking about A, since A is moving up, that's because tension is the greater force. So T minus 2 mg is equals to 2 ma. Then let's resolve from B's perspective. So B will be moving down, so that's because the weight is greater than the tension. So 3 mg minus T is equals to 3 ma. Let's add them up. Once we add them up, tension gets eliminated. Although we're supposed to find out tension, but let's add them up anyway. So minus 2 mg plus 3 mg is equals to mg is equals to 5 ma. So we cross out the m's. Okay, so we know what g is equal to, but the thing is, let's calculate acceleration. So acceleration would be equal to g upon 5. Now this is not what the question wanted. The question wanted the tension. So let's use A's equation, which is T minus 2 mg is equals to 2 ma, and now we know A is equals to g upon 5. So T is equals to 2 upon 5 mg plus 2 mg. So 2 plus 2 upon 5, that's equal to 0.4 plus 2, so that's 2.4, which is equal to 12 upon 5. So 12 upon 5 mg, this is what the question wanted, and this is the answer to the first part. Let's write it here. Okay, now let's talk about B, part B. Find the speed of B at the instant it strikes the surface. Okay, so if you think about it, B will move down, obviously. Its initial velocity is equals to 0. Okay, and what we're supposed to do is we're supposed to find out the final velocity. And we know the distance it's going to move, and we also have the acceleration. Okay, from the previous part, we have the acceleration, which is equal to g upon 5. Okay, now, so yeah, so 2as is equals to v square minus u square. This is the equation which can be easily used here. A is equals to g upon 5, so 2 into g upon 5 times s, which is equal to 0.5, is equal to v square, what we're supposed to find, minus 0 square, because the initial velocity is equal to 0. So obviously we'll have to use a calculator. G is equals to 9.8, so 2 times 9.8 times 0.5 divided by 5. Then when we take the square root of it, we get v to be equal to 7 upon 5 or 1.4. Okay, so v is equals to 1.4 meters per second. There you go. That's the answer to part B. Now let's have a look at part C. Part C says, in the subsequent motion, A does not reach the pulley and B does not rebound after it strikes the surface. Find the time from the instant when the system is released from rest to the instant when A first reaches a height of 1.06 meters above the surface. Okay, so very important, the first time it reaches the height of 1.06 meters above the surface. Let's use a fresh page here. Okay, now, so what does that mean for B and what does that mean for A? So first of all, notice this is how the story starts. Okay, and as soon as the system is released from rest, okay, so we need to first understand the sequence of events here. As soon as the system is released from rest, what happens? This moves down. Okay, this moves down. What distance? 0.5 meters, obviously, because it was 0.5 meters above the ground. And what happens to A? That is, A will obviously move 0.5 meters further above. Okay, that means now it is a total of 1 meter above the ground. Okay. Now then what happens? As soon as B hits the ground, okay, the string becomes slack. Okay, what happens? The string becomes slack. So when the string becomes slack, and because since A was already moving up, that means it had some velocity. And by the way, the velocity with which B hits the ground, okay, is the velocity with which A rises just before the string becomes slack. Okay, and that would be 1.4 meters. Okay, so that would be the initial velocity of A, 1.4 meters. And then what happens? As I mentioned, the string becomes slack, and as soon as the string becomes slack, the A will move further up because it had the certain velocity, which was 1.4. It will continue to move up until it reaches the final velocity of 0. Okay, and as I explained earlier, this was just before the string became slack. It was already 1 meters above the ground. Now we need to find out how long will it take to move a further distance of 0.06 meters. Okay, so it all boils down to how long will it take to move 0.06 meters. Okay, and this is under gravity. Why? Because the string has become slack. So this is where A was, and this is where it was after we hit the ground, and this is where it is now as soon as the string becomes slack. Okay, so now let's talk about the time to travel 0.5 meters up. Okay, so first let's calculate the time to travel 0.5 meters up, and this is when the string was taut. So what can we use over here? We have the distance, that's 0.5, we have the initial velocity, which is 0. We also have the acceleration. The acceleration will be the same as B because the whole thing is connected. So this is the appropriate equation. S is equals to ut plus half at squared. If you cannot jump to this conclusion directly, that's fine, just do a bit of trial and error. So S is 0.5, initial velocity is 0, 1 upon 2, A is g upon 5, t square. Okay, so let's work this out. So 0.5 times 2 times 5, okay, divide by 9.8, take the square root of it, so you have 5 upon 7. T is equals to 5 upon 7. Not the final answer, obviously, this is the time taken to travel 0.5 meters above the ground. Okay, now we need to calculate the time taken to travel 0.06 meters up. Because it was already 0.5 meters, then it traveled another 0.5 meters, now it's 1 meter above the ground. Now we need to calculate the time it takes to travel 0.06 meters up, and this is when the string is slack. And if the string is slack, that means its motion under gravity and the acceleration due to gravity will be used, which is negative 9.8. Why negative? Because it's moving up. So once again, the appropriate equation is S is equals to ut plus half at squared. Now we don't have a lot of space, so let's be efficient from now on. The distance is 0.06. The initial velocity of A will be the final velocity of B just before it hit the ground, plus 1 upon 2 into minus 9.8 t square. Now, I'm going to save you a bit of time, and I will give you the equation that we get after simplifying. Okay, so after simplifying, the equation that we get looks like this: 4.9 t square minus 1.4 t plus 0.06 equals to 0. Okay, it's just a matter of cross. In fact, you don't even have to cross multiply, just divide minus 9.8 by 2, you'll get 4.9. Shift it across the equals to sign, and this is what you get. So that means at this point, we have no option but to use the quadratic formula. I mean, you can do, I wouldn't recommend this to do middle term breaking because that's going to be a nightmare, honestly. Okay, so just use the quadratic formula. We don't even know whether we can do middle term breaking here or not. So minus minus, so minus minus will eventually become plus. Yeah, so minus minus b plus minus square root of b square minus 4ac. So square root of minus 1.4 squared minus 4 into 4.9 into 0.06. Okay, so that's b square minus 4ac divided by 2a. So divided by 2 times 4.9. Okay. Now use your calculator over here. First work out the value of the positive sign, then work out the value with the negative sign. One value you will get will be 0.233. The other value that you will get will be equal to t equals to 0.0525. Now this begs the question, they're both positive, that means they both can be considered. So which value are we going to use? Well, notice the question said that we want the time when it is first a height of 1.06 meters, when a first reaches a height of 1.06 meters. Now what's important to understand over here is that it will reach a height of 1.06 meters not once but twice. Why? Because once on the way up and once on the way down. So since we want the first time it reaches a height of 1.06 meters, we'll take the smaller value of t. So that means we will not take this value, we will take this value. Now what is now the total time? The total time that it takes to reach a height of 1.06 meters is equal to the time that we worked out earlier, which was 5 upon 7 plus this time, which is 0.0525. Now if you work this out and give your answer correct to 3 significant figures, so you have the total time t is equal to 0.77 seconds, and that is the final and the correct answer. So that's the answer to part C. Was it part C? Was it part B? I think it was part C. Yeah, I should have mentioned here. And that is also the end of this question and also the end of this paper. So let me know once again what your thoughts are about the difficulty level of this paper, what questions you think are easy, which ones you thought were difficult. And that's it. I'll see you guys inshallah in the next video with another paper. So take care. Allah Hafiz.